Dalton's atomic theory. His atomic theory is made up of 5 postulates, the first being that all matter is composed of extremely small particles called atoms. His second being that all atoms of a given element are identical, having the same mass, size, and chemical properties. The atoms of a specific element are different from those of any other element. His third is that atoms cannot be created, divided into small particles, or destroyed, just like America. His fourth is that different atoms combine in simple whole number ratios to form compounds. And his fifth is that in a chemical reaction, atoms are separated, combined, or rearranged. J.J. Thomson, an English physicist, began a series of cathode ray tube experiments in the late 1890s to determine the ratio of its charge to its mass. By carefully measuring the effect of both magnetic and electric fields on a cathode ray, Thomson was able to determine the charge-to-mass ratio of the charged particle. Now, with the cathode ray experiment, there was a tiny hole located in the center of the anode produces a thin beam of electrons. A phosphor coating allows the position of the beam to be determined as it strikes the end of the tube. Because altering the gas in the tube and the material used for the cathode have no effect on the cathode ray, the particles in the ray must be part of all matter. The fact that the cathode ray is deflected in a magnetic field indicates that it is composed of charged particles. Because the cathode ray is deflected towards the positively charged plate by an electric field, the particles in the ray must have a negative charge. He then compared that ratio to other known ratios. Thomson concluded that the mass of the charged particle is much less than that of a hydrogen atom, the lightest known atom. This indicated that Dalton was wrong, and that atoms were divisible into smaller subatomic particles such as electrons, protons, and neutrons.
Ready?
J.J. Thomson's plum pudding atomic model proposed that negatively charged electrons were distributed throughout a uniform positive charge. Rutherford's nuclear model of the atom explains the results of the gold-foil experiment. Most alpha particles pass straight through, being only slightly deflected by the electrons that it touches, if at all. The strong force of repulsion between the positive nucleus and the positive alpha particles cause the large deflections. This means that there is empty space within the atom and that this disproves the plum pudding model. The Bohr model, introduced by Niels Bohr in 1913, depicts the atom as small, positively charged nucleus surrounded by electrons that travel in circular orbits around the nucleus. Similar in structure to the solar system, but with the attraction provided by electrostatic forces rather than gravity.